A modern automated assembly line represents a masterclass in coordination. Thousands of moving parts, robotic arms welding automotive chassis, and materials flowing in perfect synchronization operate continuously without manual human intervention. Before the 1970s, industrial control was a purely physical challenge. Factories relied on massive, hardwired relay panels to manage machinery. Every logical step required a dedicated electrical connection. Modifying a process meant shutting down the entire plant to manually rewire panels, causing crippling downtime. Physical wiring could not sustain the increasing speed of industrial innovation. Scaling up required a shift toward digital memory. The programmable logic controller, or PLC, solved this by replacing mechanical relays with software-based logic. Engineers could finally reprogram a machine's behavior without moving a single wire. Rockwell Automation and its Allen Bradley brand pioneered this technology, establishing the foundational control standards that govern North American industry today. Early digital factories often struggled with data silos, where critical information remained trapped inside individual machines. Rockwell's connected enterprise architecture breaks these silos using a 4-layer stack: the physical layer, the control layer, the network layer, and the information layer. Rockwell Automation integrates these layers to form an industrial central nervous system, connecting the shop floor to the front office. The physical layer serves as the factory's muscles and senses. This includes sensors, safety relays, and variable frequency drives. A variable frequency drive, or VFD, like the PowerFlex line, physically moves machinery by precisely controlling the speed and torque of electric motors. The control layer acts as the brain. At the entry level, Micro 800 controllers handle logic for simple, standalone machines. Larger operations require more processing power. CompactLogix controllers manage medium assembly lines, while ControlLogix systems support massive, high-availability operations like oil refineries. Engineers program these brains using Studio 5000 software. This environment uses a tag-based architecture, meaning variables are assigned descriptive names like conveyor start, rather than numeric memory addresses. Standardizing hardware and software allows factories to scale their logic seamlessly, whether they are managing a single water pump or a redundant power plant. Smart controllers are only effective if they can communicate instantly. This requires the network layer. This diagram illustrates the CIP safety architecture. CIP provides a unified language for routing data across the factory over standard Ethernet IP cables. Industrial networks require absolute determinism, guaranteeing that a data packet, such as an emergency stop command, will arrive within a precise millisecond range window. Modern networks also support legacy systems. They integrate with older protocols like Modbus, a serial communication standard from the late 70s, allowing decades-old machines to communicate with modern controllers. This deterministic network ensures that if a safety hazard occurs, the physical layer halts instantly and predictably, preventing catastrophic failure. Information eventually reaches the visualization layer. Human operators interact with machines locally using panel view human-machine interfaces, or HMIs, ruggedized touchscreen displays mounted at the edge of the process. At the plant-wide level, SCADA systems, supervisory control and data acquisition, use the Factory Talk suite to aggregate data from thousands of controllers into a central dashboard. Rockwell's tight integration between Factory Talk and Studio 5000 is optimized for North American infrastructure, often offering a more unified ecosystem than competitors like Siemens and their TIA portal platform. This visualization layer translates millions of raw sensor readings into actionable human intelligence. Industry 4.0 centers on the convergence of information technology and operational technology. This creates the Industrial Internet of Things, or IIoT, a network of connected devices that share real-time data to optimize production. This connectivity enables digital twins. Software like Emulate 3D allows engineers to simulate and test an entire production line in virtual reality before purchasing any physical materials. Edge computing processes this data locally at the machine. Factory Talk Analytics then performs predictive maintenance using AI to identify abnormal vibration or heat patterns and resolve issues before a breakdown occurs. Modern factories now function as an active intelligence, capable of predicting and preventing their own failures. This rapid technological evolution has outpaced the available workforce. leading to a global skills gap in automation engineering. The demand for expertise creates significant career opportunities. Rockwell Automation supports this growth through certificate programs and workforce development to train the next generation of industrial problem solvers. Rockwell Automation orchestrates the global digital thread, the seamless flow of data across a product's entire lifecycle, from design to delivery. Mastering the intelligent networks that bring machines to life defines the next stage of global manufacturing.